شباب إن شاء الله we will continue our discussions on induction machine topics. So in these slides شباب يعني during these weeks we will cover the following objectives, which are learn the different modes of operation of the induction machine. Now all what have been covered in our discussions شباب is regarding the machine operation in motoring mode only. Do the machine working in any other mode? This is what we are going to discuss. Then we will cover the speed control of three-phase induction motor using many techniques: voltage control, adding resistance, frequency control, pulley changing, variable voltage, variable frequency, or constant flux, slip energy recovery, and how we can implement any speed control of these types, and we will solve some problems to recognize how we can make speed control for induction. This is considered part of the dynamics, by the way. Dynamics means studying the motor performance at any change in speed control, in starting, in braking, all of this called machine dynamics. Besides, we will discuss the starting of the induction motor, what is the problem, how we can solve the problem of induction motor starting. Then we'll discuss the electrical braking, what's the meaning of braking, why we need to make brake for the motor, how we can make brake, and what are the different braking techniques. Then we will solve some problems on these braking techniques. So this is inshallah hopefully to be covered within these 2 weeks, starting from today inshallah. And we will start step by step, and by the end of this chapter we will have some solved problems. We can make it as a help session as we made for synchronous machine. Starting from modes of operation شباب. Modes of operation means the different modes that the machine can operate, which means we have now induction machine. For induction machine, the characteristic what we have discussed later is a relation between torque and slip. So it's T as a function of S, or we can say T as a function of N. This is the characteristic of the machine. Right, now شباب, if we change the value of slip from -1 to 2, or a range from -1 up to 2 per unit, the characteristic of the torque will be as shown in شباب. You will find that it will start like that and continue, and then all of these will be for positive value of torque, and then the torque value will be converted to negative in this shape. Like, what is the meaning of all of these? We understood previously that from this point to that point, it's called induction motor characteristic. So this is called motoring mode. Motoring mode, where, as you can see, the machine speed is lower than the synchronous speed. Synchronous speed NS equals 120 F over number of poles. So this is called now motoring mode. All of our problems that we have discussed up till now are dealing with this mode. This is the motoring mode. However, do we need to operate the machine in generating mode? This is generating mode. As you can see, generating mode, speed is greater than the synchronous speed. And as you can see also, the torque is negative, which means torque multiplied by omega will be negative. So the power flow will be negative compared to this mode, compared to the motoring mode. And this is expected because generator compared to motor, the power flow will be inversed. How it can be inversed here? By inversing the torque sign. So this is now called generation or generating of power. So if the machine is working at that mode, the machine will work as generator. Hi. Do we have any other modes? Actually, yes. If we reverse the speed of the motor, keeping torque in positive sign, this is called plugging mode. And we use this mode in braking or plugging. Okay, شباب? How we can do that? We reverse the speed direction, keeping the torque in the same previous direction of motor. So the motor torque will be positive, however, speed will be negative from 0 to minus ns. So this will be according to a value of 2 per unit slip. So now we have 3 different modes: motoring mode, generating mode, and plugging mode. Okay, شباب? Let's discuss more a bit about each mode of operation. First, the motoring mode. If the stator terminals are connected to a three-phase supply, the rotor will rotate in the direction of the stator rotating magnetic field. This is the normal operation of induction motor that we already know, which means if you have now rotor like that, and you have stator flux is moving in this direction by speed ns, so the rotor will move in that direction by speed nr. And this is a motor shaft. So this is now called the motoring mode. And in this mode, we agree together that n is lower than ns. Right. This is what we understood in motoring mode. What about generating mode? The induction machine can be adjusted so that the speed of the system is higher than the synchronous speed. So if you have a machine and you could increase the machine speed over synchronous speed by means of mechanical power, in this case, the system will rotate in the same direction. The speed will not be reversed. However, in this case, the induction motor will produce a generating torque that is a torque acting opposite to the rotation of the rotor. So if the torque, electrical torque, is made to be opposite of the rotation of the rotor, it will act as generator. Why? Because the torque will be negative, and in this case, T multiplied by omega will be negative, which means the machine will generate power, not absorbing electrical power. So this is now considered a generator. It can be working as generator or during speed control of motor as well. How? Actually, while making speed control for any machine, شباب, there is a transient period that in this period we are going to cross the machine from the motoring mode to the generating mode. In this case, we call it as regenerative braking. Let me give you an example. If you are driving a car and you moving on a ramp, you will deliver high power in order to making the car moving uphill. But when you going downhill on ramp, do you need to deliver energy or to consume energy to drive your motor?
No.
Exactly. So we can get the benefits of this machine, if it is electric motor, by reversing the speed again to the machine. Or sorry, reversing the power again to the machine. Okay? So it's part of the mode of operation, شباب. So this is very useful for electrical cars. Electrical cars, all of time, you don't need to pay fuel or energy to move your car. Sometimes you can get some energy from the car itself. So it's for that it's higher efficiency compared to heat engine cars. Right. So this is here moving by a car on downhill on ramp like that. This is going to make regenerative braking or return energy to supply. Inshallah, we will have some examples and we'll discuss it in more details in the regenerative braking. Third mode, which is plugging mode, شباب. This mode of operation is sometimes utilized in drive applications where the drive system is required to stop very quickly. Let me give you an example. If you would like to turn off any motor, you will shut down the supply. Is it going to be turned off or not turned off, stopped at zero time, or it will take some time to dissipate the stored energy, the stored kinetic energy? صح يا شباب؟
Yes.
It will take some time, صح كده? In order to
Yes.
dissipate the stored mechanical energy. طيب, if you are driving your electric car and suddenly you find an object in front of your car, what will you do? Are you going to stop the car by turning off the car, or you have to use your brake?
Brake system.
So we have to use our brake here. So we need braking يا شباب in very fast stopping. We need to make very fast stopping because of sudden event or something will happen or dangerous things. تمام يا شباب. So in this case we need very fast system to be stopped. How we can do that? We can do that in the motor, for the machine in plugging mode. Let me give you a small example. Now, this is our characteristic. This is our machine characteristic. And you are working here at a certain point on the machine. So the operation here is considered as motor, because this is speed, this is torque, and this is speed. Okay. If you need to make braking for car, you have to move to the other quadrant. We call this as quadrant. تمام. But as you can see here, the speed is reversed. صح يا شباب? At this portion here, speed is reversed. مظبوط? So how we can do that? If we have three-phase induction machine, simply by converting the phase sequence from ABC to ACB. What will happen to the electrical flux, the rotating flux? If we reverse the phase sequence,
It will rotate in the other way.
It will rotate in the opposite direction. تمام. But you don't need to operate the machine in the opposite direction. You need to make it fast stop. So you need to disconnect the machine if it is operated at that point or that point at zero speed. صح كده? So after reversing the speed direction, you can stop the motor at zero speed. So you will not stay until the motor direction be reversed. Just by applying the phase sequence change, you have to have a speed sensor which will recognize the machine speed and direction, and at zero speed it will stop the machine. تمام يا شباب? So this is one of the braking techniques. We use it. It's called counter current braking. We'll discuss it inshallah in more details. In this condition يا شباب, we are going to operate the machine at this mode here. Okay, so this is called plugging mode. Okay. So this is an example for plugging يا شباب.
Sorry, Doctor, regarding the braking. I don't know, but now the system in the cars, it's I think different than this counter braking system. Am I right?
Whatever the technique, it's not a condition to be counter current braking. We have many techniques of braking. تمام? Based on the machine, the motor and car design and the weight of the car, we can start to make analysis and select our suitable technique. And it needs some analysis and design in order to select which technique of braking is suitable to our system. So it's not common for all of induction motors, تمام? And all of machines. It's according to the load. ماشي?
Actually, my doubt, what are the applications we can just implement this counter current braking?
We will discuss it in details. After understanding the meaning of counter current braking, we will discuss it in details and which application we may need it. Okay. But for here now, we just need to understand that we have three different modes: plugging, generating, and motoring mode. And the relation between the three modes in terms of speed and slip. So now, شباب, we agreed together that motoring speed will be less than ns and slip will be from the 0 to 1. Generating mode, speed will be higher than ns, from ns to twice ns, and slip will be from 0 to -1. Why -1? Because at that point, if you calculate n here, at that point n will be 2ns, so s here will be ns minus n, which is 2ns over ns. So you will find the relation is ns minus 2ns over ns. So the relation will be minus
-1.
ns over ns. It's -1. صح كده يا شباب? So here
Yes.
slip is from 0 to -1. But for the other third mode, for plugging mode here, we have a span from 0 to -ns. So here, if you substitute in the relation, so s equals ns minus n, which is final point is minus ns over ns. So you will find here 2ns over ns, which is 2. So in slip from 0 to 2 per unit, the mode is plugging mode. تمام كده يا شباب? How we can control the machine to work in the three different modes, and we are going to discuss it inshallah in more details. Fine. Starting from the importance of تفضل.
What's the plugging mode?
Again, plugging mode, we need to reverse the speed direction. As you can see here, n is negative and torque is positive. Why we need it? We need it for one of the applications like braking. So in this mode here, we can make braking. Okay. تمام؟
Okay, تمام.
تمام. Okay. Now, شباب, starting from in one of the important topics of induction motor is the speed control. I know previously in EE360 course you may learn the meaning of speed control. However, it's not discussed in more details. Inshallah, in this course we will discuss the speed control of the machine in more details, and we will analyze the performance of the machine and the technique of the speed control and which technique is better and when we can use it according to our needs. Type. Starting from the definition of speed control again, speed control is nothing but controlling the curve of the machine. So if we control the curve of the machine, we can control the motor speed. How? We discussed before the meaning of operating point, which is the intersection between load torque and machine torque, assuming we have here TB as constant load torque, TL constant. So this is our operating point now, شباب. In order to control the machine speed at the line of load, so we need to move this characteristic, move it in any shape or by any technique. This is called now speed control. Right. Starting from the parameters of our machine, we can say now, as you can see, torque is proportional to slip. What are the parameters that we can use in order to change torque with slip, شباب? Firstly, you can see V. So we have voltage control. Also, we have R, and we discussed the effect of R in previous class. Effect of resistance. We will discuss it here in more details. What exactly the effect of rotor resistance in the characteristic and how we can add it and what is the advantage and drawbacks and the effect in economical operation of the machine if we add resistance. Stator resistance is not preferred because it makes more losses compared to rotor resistance. So no need to use R1 for controlling torque speed characteristic. Here, X equivalent, you know, X equal 2 by F multiplied by L. صح يا شباب? So we can control by using frequency. So if we change the frequency here, we can control the characteristic as well. Omega S, you know, omega S equals 4 by F over P. So controlling frequency and controlling number of poles can control the synchronous speed. So these are the parameters now. V, R, F, P. 4 parameters we can use in order to move or change the motor characteristic, and by this way we can control the speed according to our load now. Type. We have to understand, يا شباب, that at small slip, if you apply here S very small, you will find that the value R2 prime over S will be very high compared to R1 and also compared to X equivalent. So if you neglect here X equivalent and R, just for approximation, you will find the relation is 3 V square S over R2 prime omega S. So this will be the relation of torque that we can use at small slip. Small slip means all of time, this part يا شباب, from this point to that point. These are the linear A, or the point that representing linear part of the characteristic. يعني before of the A, maximum torque. This part is considered small slip. يعني actually I plotted the curve here, or the curve is plotted يعني not sharp like the exact characteristic. And it may be very sharp يا شباب. ماشي? For that, we can assume the linearity of TS characteristic. So we can say finally torque is proportional to S like that. Okay, so this is for the linear part. Type. We have some other relations for starting torque and for maximum torque. We can discuss it later, but for now we need to understand the effect of speed control, and speed control all of time will be operated in this part, linear part, because other parts are not preferred. We discussed previously that this part here يا شباب is unstable. صح؟ شرحناه ولا يا شباب؟ Did we discuss the stability of the induction machine? فكروني يا شباب. Did we discuss it here or in lab?
I think in lab, doctor.
In lab, not here. طيب. While يا شباب we work in this range and we do not operate the machine at that range. And if you remember in the experiment of adding resistance in machine lab, we plotted the curve up till a certain point. We call the machine is hunting at that point because it started to go to the unstable region. But what's the meaning of unstable region? Simply, we discussed before. Let me make another slide here to discuss it in more details. You know the dynamic equation for the motoring case: electric torque minus load torque equals J d omega over dt. طبعا the equation is plus b omega plus something else k as a function of theta. تمام. However, we can neglect these parts and consider only the part of inertia. So now we have T electric minus TL equals J d omega by dt. Let's see يا شباب what will happen on the characteristics here. This is not the accurate characteristic, however, it's referring to the direction of increasing or decreasing. If we operate the machine at that point, point A, and we have T electric is greater than TL. If electrical torque is greater than load torque, what will happen to the machine يا شباب؟ This term will be positive. صح كده؟ And this means d omega by dt will have value, which means the machine will accelerate. مظبوط؟ So at that point, if the torque electric increased due to any disturbance, and this is our load torque, what will happen? The machine will accelerate. طب what is the direction of acceleration يا شباب? To the right or left? This is N.
Right.
جميل. So this means the machine will move on this direction. طب if this direction now going to over tackle the problem of increasing electrical torque, it will increase the electrical torque more. If we move the speed in this direction now, it will make more acceleration. صح ولا غلط؟
Yes.
طب more acceleration means T electric will be very large compared to T load, which means if a disturbance happened here and torque electric became greater than TL, it will not be returned back again. So it needs, in order to return it back again, it needs forced technique, which is closed loop control, that have to return the operation to the certain point again. So this is now considered as unstable region. However, let's see together if we are working at point number P here. If we have the same example, T electric is greater than T load. So the machine will accelerate. صح يا شباب؟ If the machine accelerates, this means the machine, we have now our curve like that. This is TL as it is, تمام? And T electric is greater than TL, so this means the machine will be accelerated. So it will move in that direction. طيب what will happen if the machine is moving in that direction now يا شباب?
It will return back to its origin point.
If you go in this direction here, for instance, at that point, okay, you will find T electric is lower than TL. صح ولا غلط? If T electric became lower than TL, this means the machine will decelerate, which means it will return back again. صح ولا غلط? So this is here representing stable region. And as you can see from the curve direction, this can be happen up till the peak point here. So from this point to that point, we consider the machine as in stable region. However, from that point to that point, the machine is working in unstable region. It's not impossible to operate the machine in unstable region. However, you need closed loop control. Okay, but for open loop control, it's impossible to operate the machine in unstable region. So we prefer to operate the machine all of time in the stable region. So turning back again to the characteristic, we will care about the linear part, which is representing the stable region of the induction machine. So now our target is to move this line يا شباب, or consider only this line during speed control. تمام? How we can move this line? So we discussed now 4 different variables: V, R2 prime, F, and number of poles. So we classify the speed control يا شباب in 2 things or 2 parts. One is related to rotor side, because we have 2 different types of machines. We have slip ring, and for slip ring induction machine we can add resistance. However, for squirrel cage we cannot. So let's classify the speed control according to the motor type. So we have rotor side control. So this can be applied only on slip ring induction machine or wound rotor induction machine. This is nothing but adding resistance to rotor. So here we control using R2 prime. This is depending on something called the slip energy recovery. We will discuss it in more details. It's advanced technique. However, it's based also on R2 prime. So based on the effect of resistance, we are going to make a technique called slip energy recovery. This technique is much more preferred compared to adding resistance or physical adding resistance. Okay, here we will have the effect of adding resistance on the characteristic without adding a physical resistance, and also it will increase the efficiency of the machine. So, and it's advanced, it's considered as an advanced technique, but it's based on the characteristic of moving or changing the value of R. So this is now classification according to the rotor time. So from the stator side, شباب, we said we have R, we have poles, we have frequency, we have volt. All of these parameters, 3 parameters, are applied on the stator side. So first one is only for slip ring induction motor. Second techniques, is it for squirrel cage only or for both?
I think for both.
Both.
For both, exactly. So this is for squirrel cage, okay, and slip ring as well. Both of motors can be controlled using these techniques, which are stator side control, which are nothing but voltage, pole, and the frequency, as we discussed. Type, what is V over F? Actually, we have V and have F. We have F. Why we use V over F, we will discuss in more details why we need V over F, and we will find that V over F is one of the best control techniques for induction machine. ماشي شباب? So these are the different techniques we are going to discuss inshallah in speed control of induction machine. تفضل اللي عنده سؤال.
Yes, Doctor, what is the difference between voltage control and voltage variable, V over F?
V over F control. V over F control, we make it in order to keep flux constant. So if you control the voltage only, flux is not constant. If you control frequency only, flux is not constant. However, if you control V over F and keeping V over F constant, flux will be constant. So we can call it flux or constant flux control or V over F control. And by controlling the flux, you can control the performance of the machine. If you have a problem with the machine flux, you will have a very big problem in the machine. Actually, شباب, in modern control techniques, we care all of time about flux. For that, advanced control techniques of induction motor are controlling flux all of time. So for that, we have technique called direct or field-oriented control. Field-oriented control. Okay, we have something called direct torque control, and the basics of these techniques are decoupling between machine torque and the flux, and we control the machine flux. And by controlling the machine flux, we can control the speed of the machine and all of machine parameters. We can control current. We can control everything in the machine. So this, the most not recent, but field-oriented and direct torque, it's now more than 30 years, I believe. Okay, it's a long time ago now. However, we have advanced techniques that are applied in research now. Something called model predictive control. Model predictive control. This is currently used in research, and the companies start producing some enhancement to these models in order to be used in industry. However, it's not used in industry yet. This technique was theoretically exist not for electrical motors, for other applications, not for electrical applications. This was exist long time ago. However, recently, because of the revolution in power electronics and digital controllers, we could apply model predictive control to electrical system because it needs very fast system. Okay, شباب? So we can use model predictive control now for controlling the machines. For that we care about flux. يعني all of these techniques يا شباب are based on flux control or decoupling between flux and torque. This is very important. For that شباب flux is very important. So we care here to make V over F constant to keep flux constant, which means to control the value of flux. تمام؟ To control the machine performance. طيب. طبعا ان شاء الله we'll discuss it in details with the characteristic and how we can implement this experimentally in industry. Let's start with one of the techniques which already we discussed in our labs. يعني we discussed, I know we discussed in more details. هل في حد يا شباب في الكلاس هنا ما بيحضرش معايا اللاب؟ في حد مسجل في الكورس بدون اللاب؟ فكروني بس.
نعم دكتور.
طيب اوكي. How many شباب؟ Can you please raise your hand? اوكي. تمام. شكرا شباب. طيب يعني we will discuss it إن شاء الله in details also. Now let's see together the effect on the boundary. What are the boundary? What is the meaning of boundary? We have 3 points يا شباب. We have the point of synchronous speed, this point. You know NS equals 120 F over P. You have T maximum. You know the relation of T maximum. It's proportional to V square over R1 plus square root of 2 R1 square plus X equivalent square, all multiplied by omega S. صح كده يا شباب؟ We have also Sm at the same point, which is corresponding to maximum torque. Sm equals R2 prime over square root of 2 R1 square plus X equivalent square. Third point is T at starting. Let's move again to the relation of torque. Here what we have. If you have S equal to unity, this is at starting. صح ولا غلط يا شباب؟ مظبوط؟
Yes.
At starting S equals 1. So what do you expect the values of R square, summation of R square compared to X equivalent square? It should be very small compared to X equivalent square. صح يا شباب؟ For that, we can neglect this part and keep this part. So in this case, we can say 3V square R2 prime over X equivalent square omega S. مظبوط كده؟ This can represent the starting torque. So finally, you will find that T starting is proportional to R2 prime. So if you increase R2 prime, the value of T starting will be a increase. So let me write the relation again here. So T starting is proportional to V square R2 prime over X equivalent square omega S. صح كده يا شباب؟ مظبوط؟ This is now the relation of T starting, or approximate the relation of T starting. In order to understand يا شباب how the characteristic will move, you should recognize the 4 relations. As you can see, NS is constant. What's the meaning of constant? Constant, which means in this case, in adding resistance case, because NS is not a function of R2 prime, so if you change the value of R2 prime by any value, all of curves will start from that point. And this is the shape as we can see here يا شباب. صح؟ All of curves by adding resistances, it will start from the same synchronous speed. Why? Because synchronous speed is independent of resistance. طيب, what about T starting? As you can see here, by increasing R2 prime, T starting will increase. This is mathematical يا شباب, صح? Is it clear? So as you can see, if you add more resistance, value of T starting is increasing. ماشي. However, يعني value of R here is greater than that value. So this is valid only until having T starting equal T maximum. يعني look at this curve. This is, we call it as natural curve. Natural curve, which means external resistance equals 0. We don't have any added resistance here. So this is called natural characteristic. If we add resistance number 1 by certain value, you will find that T starting increased from T, let's say T0 at 0 external resistance to T1. Now, adding more resistance to be R external 2. So T starting increased to T2, which is T maximum. صح ولا غلط يا شباب؟ مظبوط شباب؟ Is clear for the figure?
Yes.
What happened here if we added R external 3 and R external 4?
Decrease lower.
It started decreasing again. Why? Because we added a resistance that higher than the value, which making T starting equals maximum torque. So the value of resistance here, which is corresponding to T starting equal T maximum, is critical value and need to be calculated. It's very important. Why? Because the target is to increase T starting. Why we need to increase T starting? This is very helpful for constant load torque, for high load torques. So we can say torque starting is increasing by increasing resistance, but with a limit. What is the limit? The limit is the point at which torque starting equals torque maximum. After that, we cannot apply this A relation. However, this is at starting, not speed control. At speed control, you can do what you want. You can add more and more resistance. Why? We just need to make speed control. As you can see, we have here point of the intersection with this load type. We have here load type, which is fan here in this case. So you have speed 1, speed 2, 3, 4, 5, and if you add more resistance, you will have more speeds. So this is the effect on T starting for our curve. Yani we need here to just recognize T starting point in order to recognize the characteristic shape. What will be the characteristic shape? But this has no effect on speed control يا شباب. يعني T starting value has no effect, okay, or not important in speed control. It's important only for starting of the machine. Right. What about T maximum? T maximum is not proportional to R2 prime. صح ولا غلط? So if we change the value of R2 prime, we'll find T maximum is constant. So as you can see here, for all of curves, the maximum torque is constant. So if you would like to extend this line, it will be like that. Other line will be moving like that, and so on. ماشي شباب? So this is now representing the characteristics by adding resistance. What has happened to S maximum, which is led at maximum torque? What happened to S maximum, شباب? You see, S maximum is proportional to R2 prime, which means if you add more resistance, S will be increased. And you know, S here equals unity, and here equals 0. So increasing S maximum means moving in this direction. For that, you will find this is curve for case number 1, case number 2, case number 3, and so on. طبعا from here يا شباب, we can say that T maximum or T starting equals T maximum if S maximum equals كام يا شباب here?
1.
Equals 1, right. So the critical point of T starting equals T maximum, the value of resistance can be calculated if we make S maximum equals unity. تمام يا شباب؟ يعني if you said S maximum equals R2 prime plus R add divided by R1 square plus X equivalent square under square root 2. This will be equals to unity. You can give the value of added resistance, which makes this condition. تمام؟ طيب. Now we understood the effect of adding resistance on the characteristic. We can conclude from the characteristic here that we have wide range of speed control. As you can see, the more resistance you add, the lower speed you get. So it's wide range now. So the first advantage is its wide range of speed control. الحاجات دي مهمة جدا يا شباب. يعني it can be come in the exam as MCQs. Okay? Right. Number 2, constant maximum torque. That means TL constant is allowed. دي مش هتوضح قوي دلوقتي يا شباب. However, when we discuss إن شاء الله the different control techniques, we will see that this is considered as an advantage. However, for now, we need to recognize that torque maximum is constant. يعني the time is finished now. يعني just in few seconds شباب, we prefer the use of closed loop control instead of adding the resistance manually, and we avoid using resistance manually to not having unbalance, because if the resistance is not equal for the three phases, the current will be different values and it will make unbalance in the machine. For that, we use power electronic devices either by open loop control or closed loop control. Inshallah, next class, and we will discuss it in order to get the or drive also the disadvantages of adding resistance. Right. Please, if you have any question, you can stay. If you don't have any question, you can leave, and see you inshallah by the next class.